And welcome back to Red Thread Podcast. I'm your host, Random Randy. And today we're going to be looking into mining. Wanted to get this information out to you guys because I think it's very relevant when we're looking at what has happened to this place, in the past. We need to understand that there are things going on that are bigger than us as individuals, that are bigger than our individual hopes, dreams, and goals in life. We're pretty much they let us know through popular culture, through the Anunnaki story, that part of the reason that we are here is to mine, right? To mine gold, precious metals, things like this. Now, some of the things that it comes to, and we'll jump back into that in a second. Some of the things, some of the questions that come up in this old world kind of study are, all right, why don't we use pure quarried stone in our buildings anymore? Why do we use things like gypsum, fiberboard, like all of these materials that we build with today? Why do we use those materials as opposed to, stone, even things like clay bricks, right? Like, why don't we just use bricks anymore? Now, there are some very good reasons that I've found looking into mining as to why we use the materials that we use. And it all has to do with the mining cycle and the way that we extract minerals and metals from the earth and from materials. Now, it may seem surprising, but the materials that bricks are made out of, red clay, hold vast quantities of things like aluminum, silicate, and other minerals that are very useful for us. So that's part of the reason. So we're going to jump in kind of headlong here. We're going to go straight into the basics. All right. We're going to go into what is mining. All right. We'll give you, what is included in mining. Okay. A lot of people will, myself included, will look at mining and just think drilling holes, blasting, but there's a lot more to it. Okay. We're going to look at some methods of mining. All right. One little bonus here is I found something in some information very interesting is there's a concept called process mining, which is the refining of practices in business. So mining, is a term also used in our day-to-day lives when it comes to other things, right? So it's very interesting, and that ties into, the alchemy of things. And we'll get into that fun stuff at the end there. But unfortunately, this is going to be a little bit dry, a little bit boring. Okay. And but it is relevant information. So it's very important to kind of understand what's going on here. Okay. So we'll get into what is mining. That we're going to look at some methods of mining. Okay. We'll look at several sites detailing the different methods that are in place when it comes to mining. Okay. Now we're going to also look at some different mining claims, a map of mining claims in the United States specifically. And there's some very interesting information within that. After that, we will look into all of the world's metals and minerals in one infographic. So we'll show you a visual of what is being extracted on your average year, specifically in 2019. Okay. Now, after that, we'll take a quick look. After we've looked at the different types of mining, we will look at some photographic information regarding the possibility of our realm or plane or planet, however you'd like, being one big mining site or quarry. Okay. And after we look at that, we will look at some of the different processes that happen when it comes to mining. So I'll throw those pictures in the middle there, just to kind of break up, some of the heavier information. Now we will look at the way that minerals consolidate underground through natural processes. We will also be looking at the reclamation of land specifically, and also how they essentially get treasure from trash, how the mining waste is then remined. Okay, so that opens up the possibility that, the realm as we see it as natural is really just the remnants of previous mining endeavors. Okay. So we will look at some specific notations of different mines changing gears, like going from one type of metal mining to another after they had completed, say, gold, and then moving on to uranium. So we will see this kind of cycle start to unfold, right? We will see how battery metals, the batteries that we use today, how these are actually extracted from mine waste, to create our power packs and batteries and things that we use. So it's this crazy, awesome kind of cycle. And then at the very tail end of it, we have recovering gold once more from the byproducts of these other mining endeavors. So it's very interesting stuff. And so, if you're not ready for an in-depth kind of dive, this may not be the episode for you. And then, at the very end, we will take a look at some of the alchemy going on here and why, it's not so scary to look at this and say, okay, is it really just mining, right? Is it really just the extraction of metals? No, it's an extraction of spiritual prowess, understanding. So alchemy, has a lot more to do with a lot more things than most people think. It's not just a chemical process. It can be a spiritual process too. So let's go ahead and get started here. There we go. All right. So first off, what are the main methods of mining? There are roughly 4 main mining methods: underground, open or surface pit mining, placer mining, and in situ mining, which is in-site mining. So underground mines, more expensive and used to reach deeper deposits. Surface mines, used for more shallow and less valuable deposits. Placer mining is used to sift out valuable metals from other sediments in river channels, beach sands, other environments. Now, in situ mining is primarily used in mining uranium. It is used in quite a few other minerals. Okay. It includes dissolving the mineral resource in place and then processing it at the surface without moving the rock from the ground. So it's just like a leaching and extracting process. Okay. So very interesting stuff. And we will jump right into the next item. Now, underground mining. Okay. And I don't have the audio putting through, which is fine. Okay. Now, when ore lies below the surface considerably, the amount of waste that has to be removed to uncover the ore through surface mining becomes prohibitive. So underground techniques must be considered. Okay. So that's when they go underground, dig tunnels, right? Remove the ore through those tunnels. Okay. It's a very expensive method. And it just depends on the size, shape, and orientation of the ore body, the grade of mineralization, the strength of the rock and materials, and the depths involved. Okay. So this would be like your more densely consolidated minerals in veins deeper underground. That's when they will go and do the underground mining. Now, the openings made in the process of extracting ore are called stopes or rooms. There are 2 steps involved in stoping. First is development, that is preparing the ore blocks for mining, and the second is production or stoping itself, so the act of stoping. Okay, so we will go ahead and just get down. One goes deeper into the earth, the thickness and the weight of the overlying rock increases, therefore adding pressure. Now, this pressure from the weight of the dirt or the earth above is a very important part of the consolidation of metals, minerals, and so on. Okay, so it's a very important part of this process. Now, mine development. Vertical openings are called shafts and raises. Okay, that's for ventilation and for the feeding of media lines like compressed air, electric, or water lines are contained in those vertical shafts. Also, they'll have conveyances for the people going down there, like elevators and things. Another way to gain access underground is through a ramp or a tunnel, right? Okay. So it's very interesting. Some of the stuff, horizontal openings are called drifts. And so it's just a lot of drilling, a lot of blasting, a lot of machining away of rock in these openings, both vertical and horizontal. So they'll drill blast holes a certain distance apart. They will set them off in a certain order. And, for a long time, it was just dynamite being used. But I guess they're kind of going to a more refined uh, sort of explosive that has less of a chemical reaction with the earth itself. So blast holes being fired in a certain order, and result, we have ore being removed by massive machines. In the olden days, we'd have just a rail in here and we would just put it in some carts and roll it on out. Hopefully our canary would stay alive so that we can remove the stuff. That just stresses the importance of those shafts to create ventilation, right? Okay. So the broken rock's removed, the roof walls and face are cleaned of loose rock. Now, once they're done mining these places out, a lot of the time, if it's a good, bedrock that they're in, they'll just turn around and repurpose that and, use it for underground storage of things like seeds or, different maybe genetic material as well as bases. So the mine is the first step. The maybe one of the later steps would be building these underground structures, right? So there's this interesting cycle that happens where we are using the end result of mining for building, whether underground or above ground. So ventilation and lighting, like I said, shafts are put in, fans and controls are used to direct fresh air, keeping people alive down there, right? Now, there are high rock temperatures underground. Okay. Some of this has to do with radioactive decay. Some has to do with just the pressure, the amount of pressure being applied to the stone and surrounding areas. Now, it depends on what you're mining, how much water you're going to use. Okay. So let's look at room and pillar mining. Now, this is common in salt mining, for example. So the pillars are left to support the overlying rock. We have the vertical and the horizontal, and we have, the drill excavating here. Longwall mining, creating a canopy under which the seam can be mined. Okay. Dividing into rectangular panels or blocks, and each panel, 2 or more parallel drifts for ventilation are driven alongside at the end of a single crosscut, okay, or long wall. Now, mining steeply dipping deposits can be interesting. So many deposits are not flat, so they're different types of mining situation. We'll just take a look through some of them here. Okay, blast hole, which is greater than 55 degrees, ore and waste strong, ore boundaries regular, and the deposit relatively thick. Blast hole stoping is used. Okay, this is what it looks like. We have the transport drift down here, like I said, a rail with carts, drilled and blast up here through a massive tunnel, and you can just kind of see that this is a piece of equipment here. So you can see how large some of these areas underground are. Okay, they'll blast it down, they'll undercut it, and they'll carry the ore out using gravity. Now, shrinkage is used in steeply dipping, relatively narrow ore bodies. Okay. Again, it's very similar to the one we just looked at. Okay. And again, you can just see the size of some of this compared to the equipment down below. Okay. Cut and fill mining. This is, a different process. Now, when you have a process like this might be the type of underground area that you would go ahead and then use for a base or something like that. So, okay, sublevel caving. This is an interesting one. They will cave in the surface, and down below this crater or cave, they will have, different tunnels, different areas here, blasting, using gravity to drop this material down, and then pulling it out through yet another tunnel underneath. So, very interesting stuff. It really makes you wonder about craters and some of the sinkholes and things that pop up all around the world. Very interesting. What's going on underground there, right? Now, mining massive deposits looks a little bit different. You can see how much larger this kind of cross section is. And I mean, these mining situations are just huge, absolutely huge. So, you got to keep that in mind. We're talking very, very deep, guys, very deep. All right. Now, we'll kind of breeze through a couple of these here. Placer mining is for different materials: gold, tin, platinum, diamonds, titaniferous and ferrous iron sands, gemstones, rubies, emeralds, sapphires. Very interesting word, titaniferous. That's a good note right there. Okay, so placer mining, typical panning, right? Diamond mining in Africa, streams, beach placers. So this is a lot of what was going on, in 1849. Panning is another type of kind of placer mining, sluice box mining. So these are some of the ones we're familiar with, especially, if you're from the West Coast. You see a lot of this action going on in California. Now, there are some mechanized methods, right, using those sluicers. So using machines would be considered mechanized. Now, hydraulicking, stream of high pressure water, dragliner backhoe. Just this is a lot of what's happening in the Amazon and things like that. They just are scooping up, large amounts of, river sediment and things, and just sluicing them out. Dredging is the underwater excavation of a placer deposit. Okay. And we will take a look at some of the equipment for some of the types of mining, probably not all, but these things are underwater cutting, digging materials. They kind of scoop them up, it turns into a slurry, and they pump it out. Now, seawater itself is actually mined. Very interesting stuff. Okay. Because seawater contains chloride, sodium sulfate, magnesium, calcium, potassium, bromine, and bicarbonate. So the Dead Sea and the Great Salt Lake, two very notable examples of, basically of seawater or saltwater mines. What I mean by that is they are putting a brine in solution up above ground, and then they're letting that dry out, sometimes over the course of a couple years. They evaporate it, right? So common table salt, right? Epsom salt, different salts, all right, are being extracted from the earth, pumped up to the surface, and then dried out. Okay, so evaporation of seawater, right? Different sea salts. You go to the store, you buy your sea salt. Where does it come from? It comes from underwater, underground, deep sea, undersea mining. Okay, so they pump the salt water to a hot, dry climate, and this is of course some of the extraction happening in some of the more desertified areas of the world. Looks more like this. Now, Great Salt Lake, a fine example of how that's done here. And we will just go ahead and take a brief look. We probably don't have the audio up, but you can see here how the water is being pumped up into these vast areas. Kind of makes you wonder about what's going on with the creation of the Great Salt Lake, right? Is it by design that that entire area is dried out and turned to salt, which they then come back behind and scoop right on up, goes to the grocery store, and winds up on your dinner table? Okay. So very interesting stuff. Evaporation brings the sodium chloride levels to saturation. Then they, dry it out. Usually takes in the Great Salt Lake about a year that the salts are dwelling in that pond. So very interesting stuff. Um, the evaporation for other minerals. Okay. Marine beaches, micas, feldspar, other silicates, as well as quartz. Um, very interesting stuff. There are a lot of heavy minerals, in the earth, right? Lots of stuff going on. Dredging, hydraulic suction dredge, okay, to remove overburden or, the overlying silt so that they can get down to the good stuff, right? So the sea floor is another area that's mined out, okay, containing calcareous ooze formed by the deposition of shells, skeletons, plankton, etc. Okay. Um, so this underwater silt has a composition similar to that of the limestone used in the manufacture of Portland cement. Now, also red clay on the ocean floor. Okay. Aluminum is present, copper is present in that red clay. So these may be some of the reasons that you would want to reclaim some of that brickwork for later use, especially once you find out how to extract some of the minerals and metals from it, right? And we have areas like this underneath the Red Sea and deep in the Atlantic Ocean. Okay, so under the ocean, we have vast quantities of minerals and metals and things like this. Kind of makes you wonder about those oil rigs. Are they all pumping oil or are they pumping other things? Okay, so that's solution mining, brine solution mining, right? Lithium, boron, potash, Glauber's salt, halite. Okay, they drill boreholes in the top of the salt formation. Then they run water through and it falls down, resulting in a morning glory shape that is wide at the top, narrow at the bottom. Okay, they pump water in the top, flows down, they extract. Okay, so had to reach down and grab my notes there. Now, so that's some of the different ways that mining is performed. Sulfur recovery. Okay. They recover the sulfur from an overlying salt dome. Okay. Using hot water. And they perforate the stone, superheat the water, pour it through, creating, a molten type sulfur, a liquid sulfur, which is heavier than water, sinking to the bottom. So those are just some of the methods, and we will dig a little further into this. Let's take a look at coal mining. Okay, using large machines to remove coal from the earth. What they do is they, pull out the overburden to expose the coal seams. Now, all around the world, we have this layer of, sometimes in some places it's black earth or terra preta. In other areas, it has undergone the chemical change through pressure to create coal seams. All right, meaning that it has had enough pressure on top for long enough, and the exact details on the time frame that it takes to create that effect. Hey, I'm not 100% on this, but there are several methods. Pressure being one. Electrolysis creates chemical and compositional changes in stone and in organic matter also. So that's something to keep in mind. Now, surface mining is used when coal is less than 200 feet underground. 200 feet is still a lot of overburden, quote, to remove, right? So it looks like this. Okay. Topsoil, very thin, overburden, and a shallow coal seam. Now, deep mining, on the other hand, looks very different. You might have some small infrastructure up above, for extracting the ore from the products that are brought up. But most of it's taking place underground, and we just don't see that. Okay. We don't see it. Coal mining is one of those. Now, uranium, open pit, underground, and in situ leaching. Here's something interesting. Open pit mining, known as strip mining. We will take some pictures or look at some pictures of that here in just a little bit. Now, we have these massive mining areas, and look, right next to them, we have the Laguna Pueblo. These areas are villages, essentially, being used to operate these mines. So, it puts out the option or the question of, were the natives in all areas of the world, were they really native, or were they brought to these locations strategically to complete these projects, right? It's a very interesting possibility. You do have to have areas for folks to live and have a somewhat, kind of happy existence where they will be motivated to go to work and to mine. So you have to have, things set up, right? That way your workforce is essentially happy. You don't want an unhappy workforce. They will revolt and, crash the system, right? So the positives of open air mining is less expensive, better ventilation. Um, and here's an example of an open pit mine in Canada. Okay, and we will take a look at a lot of those. The negatives is a huge footprint. Waste rock piles can be enormous. Remediation is extremely costly and time consuming. Groundwater restoration can be costly. So there are pluses and minuses with all sorts of mining. Underground mining, we were looking at a few examples there. This is an example of a schematic from McArthur River, Canada. So we have different shafts going down for ventilation, like I was saying, different slurry holes where they pump the solutions into or out of. And, uranium is one of those that they turn into a slurry and then pump up. Okay, it has a smaller surface footprint, but there's still a lot going on underground. Less waste rock. It's very expensive though, right? Potential to impact local aquifers and expensive to remediate. Now, milling. Okay, for both traditional underground and open pit mining, the rocks may only have a few percent uranium in them, has to be removed from the rock and concentrated. So there's this massive refining process. The ore brings in from the mine, it is crushed, sampled, ground, leached with different chemicals, pumped in through washers, and then part of it goes into a thickener. It is, then pumped from the thickeners into the extraction circuit, where it encounters a salt solution, ammonia, is precipitated, filtered, dried, packaged, and finally yellow cake uranium. Okay. So it's a very interesting alchemical process taking place here. Keep in mind that through this extraction process, we create a massive pile of what is known as tailings. Okay. So we will look at some of the results of mining here again in just a little bit. So recovery mining, in situ mining, leach mining, okay? Pump water and add oxidants such as oxygen, okay? Baking soda sometimes, okay? Helps the uranium dissolve into solution. Okay, this oxidizes the uranium in porous sandstone, making it easier to go into solution. Oxygen-rich solution is pumped down injection wells within a well-field pattern. The solution moves through the rock, dissolving the uranium in the ground. Wells are at a prescribed distance, pump uranium enriched water to the surface. Okay, now these pumps pump more fluid than is put down the hole. They create a cone of depression. Right, cone of depression, looking very much like a crater. So some of the information I was showing in the last episodes, looking very much like natural craters. Could some of these things be being created? Uh, could these have been created by some of these mining processes? So, all of this ties together, whether you consider it loose or not. The associations here. This stuff is happening to a massive extreme, in this world, and we will get into the details and how much material is being extracted from the earth every year, or at least in 2019, we have the visualization for that. So this is again another run through showing the entire kind of mining process. So keep in mind, you only see this little bit going on top. You're not seeing any of the stuff going on underground. And if they're pumping it through wells, you're not going to see trucks coming back up to the surface. So, a lot of people are like, oh, wow, these underground places are using them specifically for really dark, evil things, possibly. But I think a vast majority of it is the extraction of minerals and metals. Okay. So small surface footprint, little waste rock. Now the negatives, contamination, right, is a big one. Wastewater disposal and public fear, right? You gotta keep your workforce happy. You just do. Okay. All right. Placer mining, placer gold mining in particular. So we see a lot of this going on in California. See the hydraulic kind of pumping water into, in my opinion, a lot of this previously ground stone and stuff. This may very well be the remnants of previous mining. Okay, that then they bring us in as as humanity to work the surface stuff. Okay, hydraulic mining with sluices. Okay, so this is what we know of mining, right? 1848 California gold rush, Canadian Klondike, late 1890s. Um, this is how we understand mining happen, using hydraulic giants to thaw frozen ground in California. Hydraulic giants, massive hoses. Okay. And then they would run this down through a wash where another series of people would be down there. And then they would, molt. Look at this, turning molten Coal Creek gold into bars. So there's a very, interesting history behind all of that stuff. So here's a dredge. So they would just, get the ground all wet, use a dredge like this and dig it up and run it through sluices. Okay. So let's take a look here at some of the claims, mining claims, and, mine occurrences and mines around the, Western United States. And I wanted to start here because there's a very fascinating sort of thing happening here. And I lived in Southern California my whole life, up till about 10 years ago. And one thing I never knew about was that this part of the Sierra Nevada was called the Cathedral Range. And, there's just nothing coincidental about the naming of things, it seems, especially the further into all of these rabbit holes we get. So we have the Cathedral Range running along that side of California. Very interesting stuff. Now, when you start to look at areas like Utah, remember I was talking about the Great Salt Lake being a salt mine? Okay. Not only is it a salt mine, but we have the Desert Flower Mine, the Silkworm Mine, Pig Hollow occurrence. So we have some different types of names here. We have prospects, we have occurrences, and we have mines and claims. So, it seems to me that some of these occurrence situations here may be the remnants of older gold mining that then has deposited uranium in these outer lying areas. That's just a thought. Obviously I was not I guess, privileged enough to go to a university and be completely indoctrinated. I think I had enough indoctrination going through standard school. So no, I don't think that I know everything. I'm just pointing out what I'm seeing and what makes sense to me. And, if it makes sense to you, great. If it doesn't, oh, well. So let's take a look. So this is just, an example showing you all of the different prospects, claims all around the United States. When you start getting into areas like in Colorado, I mean, it's just dense, guys. It's really dense. Grand Canyon. Okay. Grand Canyon National Park. Check out these reservations, though. Reservations, zero claims on them mostly, maybe one. So you see why they move these people to the areas that they move them, right? The Ute Mountain Reservation. I mean, look at how few claims are within this area. So, and same here, Hualapa, right? And it's like that in most of these reservations. Okay, they're all like with the least claims in them. So it's very interesting stuff. Okay. Occurrences. Now, so I'll show you some information here in a little bit after we look at some pictures of kind of the processes and the way that, previous mine waste is then recycled through to make it treasure once more. So, there's this vast cycle going on here. And, we only see a small part of it, only living, less than 100 years. We really only see a small part. So there's this really cool visualization here. Um, and I mean, it's extreme. So let's start at the top, guys. This just shows you the tonnage of non-fuel minerals. Diamonds, 11.2 metric tons, so on and so forth. And it goes on and on. Zirconium, selenium. So you're just seeing, and we'll just roll right to the bottom, scroll right through this. You see 210,000 tons of titanium extracted in 2019. Mica, okay. Vermiculite used in planting and things. Okay. Abrasives. Some of these things you may not consider, earth extracts, but they are. Pumice, magnesium, peat, right? 30 million tons of peat. Clay, 63.8 million tons of clay. Phosphate rock, very important fertilizer. Salt, 293 million tons. Lime, 430 million. Okay, used to treat drinking water, wastewater, and contaminated soils, among other things. So these all have these are all wound in together in this cycle, right? The cycle of mining, of reclamation, of, cleaning up after the mining. It's this massive cycle. Now, cement is made with calcined lime and clay, mixed with sand, gravel, and water to make concrete. Okay, and look at how much that is. Sand and gravel, tons, and it goes on and on and on. Now, something neat to note is that apparently the world is beginning to run out of easily accessible river and lake sand, which has an angular shape that helps form stable concrete. Highly doubt it, but okay. So we're getting down here and man, aggregate, right? Rock, sand, it just goes on and on. So this shows how much of that sand and aggregate and stuff is pulled out of the earth. And you see why we're using those materials for our building now, right? I hope, I think. Anyway, top 10 minerals and metals by production. Number one, sand and gravel, 50,000 million metric tons in 2019. Cement, 4,100 million metric tons. Okay. On the tail end of that, iron and steel, iron ore, bauxite, that aluminum comes from, lime, salt, phosphate rock, nitrogen, gypsum. Gypsum being used in drywall. Okay. So you could see why we're using certain materials for our building. These are the most extracted and kind of the least valuable. These materials fertilize the food we eat, also forming the structures we live in and the roads we drive on. They are the bones of the global economy. Now, base metals being the lifeblood, right? Non-ferrous, meaning they contain no iron, often more abundant in nature and sometimes easier to mine, so their prices are lower than precious metals. Number one, aluminum. Okay. Number two, copper. Number three, zinc. Number four, lead. Number five, nickel. And number six, tin. Okay. Critical materials. Of course, they got to point out that they deliver a green and renewable future. Okay. Now, through this vast cycle of mining, renewable is an interesting term. Okay. Because it's as it seems, and I'll point out here in a minute, all of this is semi-renewable. Okay. Silver, 27,000 metric tons in 2019. Gold, 3,300 metric tons. Okay. So that just shows you, and in 2017, it's estimated that humans consumed 100.6 billion metric tons of material in total. What consumed means, who knows, right? I mean, some of the stuff is put into housing, things like this. Half of the total is sand, clay, gravel, and cement. 50.3 billion metric tons, guys. Interesting, right? Other minerals mined to produce fertilizer, coal, oil, and gas make up to 15%, while metal makes up 10%. Final quarter are plants and trees used for food and fuel. So this includes plants and trees. as extractives, right? Very interesting stuff. So should we take a look at pictures? You know what? Let's look at the process. One of the processes that consolidates precious metals within the earth. So, all right. In a nutshell, let's see if we can kind of summarize this. Now, they supersaturate the sand, right? And with changes in pressure associated with fracturing or with transport across temperature gradients in hydrothermal system, what happens is it leads to a precipitation of amorphous silica, which recrystallizes into quartz underground under typical geologic conditions. Okay. So this is the process taking place underground, whereas nanoparticles are suspended in a solution, allowing for a higher flux or integration of gold and silver within these hydrothermal systems. Okay. And when you integrate heat and water, is more than just as the solution. All right. So it makes the water more sorbent, right? If that makes sense, hopefully it does. So yeah, some of this stuff is kind of dry, but I think it's very important that we look at some of these processes that are going on. And something to keep in mind is a lot of this takes time, all right, which is something that we're not used to thinking very fondly about because we're only here for 80 years or so. So very interesting stuff. Okay. Um, Electrum is what the substance containing silver and gold within quartz carbonate rock is called. Okay. Um, so repeated rupture events concentrate the electrum even further. This is why it might be important to create some types of seismic events underground, and may possibly be why some of these seismic events are happening to create this process. Okay. Is some of it natural? Possibly. Is some of it man-made? Also possibly. Okay. Now, recrystallization of this amorphous silica to quartz may cause localized remobilization of electrum and the formation of the ore textures that are observed today. Okay. So it's just saying that these things consolidate, harden back up, and they create the ore that we then extract today. All right. So let's take a look at how mining waste can be mined a second time. Okay. And there's tons of studies and stuff out there, guys, on this. So basically, we typically look at mining as a straight line with a beginning and an end. Okay. But is that really the case? Some of these studies go on to say, no, one type of mine waste known as tailings can be then remined. Okay. Tailing dumps can be gold mines, literally, in some cases. Okay. And, with these metals being vital to the electronics industry, you're going to find as many ways to extract as much of this as possible. So, say you're mining gold and you're pumping out a slurry into a tailing pile that contains minimal amounts of like lithium, different metals for batteries, uranium, so on and so forth. You could then go back to that, mine out the uranium, okay? Mine out the uranium, much like in this notation is stated that some of these companies, and there are all these different, it's a huge long list of companies that are doing this. Tailings projects, they're called, okay? Deposit projects, tailings projects. So they're going back into their previous mine waste. And there's tons of examples of this, okay? They're going back into here, and what happens is until 1981, this company extracted U3O8 as a byproduct of its core gold production activities. Okay, so as they're extracting gold, this is a byproduct. This is, when I say byproduct, this is what I mean. This is a residual, material left over. Okay, so now they go back and now they're reclaiming the uranium. All right. And there's a process of enriching that takes a significant amount of effort. Now, let's see here. So let's take a look at coal mining. The cycle after the coal mine is done, right? Preliminary estimates indicate that waste left by coal mining activities in Pennsylvania contain tens of thousands of metric tons of cobalt and hundreds of thousands of metric tons of manganese. Okay. One metallurgical waste deposit in the Commonwealth may contain 500,000 metric tons of manganese. This is just one small area in Pennsylvania. Okay. And these are battery minerals that currently we're, getting from overseas, and we're having all these issues, right? Issues getting the battery metals or, the superconductor materials, when really what they're doing is they're pivoting. They're saying, okay, we've relocated. Now we're going to go mine gold in the Amazon. Okay. Because it's cheaper to mine there. So what do we do with our gold mines here in the United States? Well, we need to increase the demand for these battery metals that are junk. They're junk metals, right? And if you know anything about the way energy works, there's really no reason so much for a lot of these, the ways that they use these batteries and the limitations that they entail. Okay, so they're coming up with reasons and methods for using this mining waste. Okay, so you got to understand that this is part of the economy that's unfolding. All right, so let's take a look at mining waste real quick. Mining waste includes waste generated during the extraction, benefaction, and processing of minerals. So something neat to note is there are 20 mineral processing waste covered by the mining waste exclusion. Slag from copper processing. This means they can just pump it into a pile and leave it. Okay. Slag from lead, red and brown muds from bauxite refining. So they just pump this somewhere and they leave it alone. And we're going to take a look at what the reclamation of these types of areas looks like. Okay. This is why they're allowed to tell you that the shit's natural. Okay. Because it's excluded in the mining waste exclusion by that's right, the EPA. Okay. So, I mean, it makes a lot of sense to me, everything they're doing here. I'm not necessarily for or against any of it. I mean, I see it as a process that is happening, right? And it's phosphogypsum from phosphoric acid production. So then they turn around and extract the gypsum, which they use in our walls, our drywall and stuff. Okay. Calcium sulfate wastewater treatment plant sludge from copper processing, slag tailings from copper, fluorogypsum from hydrofluoric acid production. And so they extract the fluoride and the gypsum. You see why some of these materials are being given to us as sometimes food, drink. Okay. I know it's touchy to a lot of people, but we are being used as the filtration systems for this leftover. All right. Anyway, it kind of makes you wonder why we're put in steel, sealed boxes when we die, right? Because we're full of this residue from all of this crap. Okay. And if you think that the natural land that you're living on is natural, you're in for a rude awakening. If you're open to a rude awakening, anyway. So, again, so treasure from trash. Lots of examples of this. Okay. It's just this massive cycle. Okay. Let's take a look. Okay. And then gold is a byproduct from the base metals. So it just goes in a big circle, guys. Huge circle. Okay. And then, of course, we have, we ship our electronic scrap to other places. And then those people in those areas, grab up the gold and smelt all that shit out and then sell it back to us. So there's this huge cycle going on. Okay. Spoil tips. Examples of mine waste, right? We're just going to go through a few here and we will show these pictures here in a little bit. I just want to get through, the rough stuff here, the in-depth stuff. Spoil tips in Ukraine. So you can see how large areas were mined out creating. Look at that. Spoil tip known as Mount Cali or Kilimanjaro in Germany. Kind of makes you wonder about Mount Kilimanjaro, right? Interesting stuff. So that's one. Overburden is another. Uh, and that's just like I was showing earlier, the dirt that lies on top of coal mines. Okay. And it's distinct from tailings. Tailings is after the separation, the chemical separation. Overburden is just the dirt that was laying on top. Okay. And it's typically not contaminated with toxic components. Now, mine reclamation, very, very interesting stuff. This is in 2006. This is a coal mine. And this is a couple of years later. Look at that. What does that look like to you guys? Try the entire Central America, Central United States. So I don't think it's a far cry, guys, to look at this stuff. Reclaimed strip mines in Pennsylvania. This looks exactly like where I live in Iowa. Exactly, guys. 100%. Tree lines, farms. So is this coincidence? Are we living in a massive mining operation? Let's take a look at some of the pictures detailing the visual evidence, okay, of why that may very well be. So let's take a look at quarries first. Okay, Levadinsky, Magnet Mount, Russian, Chilean, US. Okay, keep that in mind as we go through these real quick. These are quarries. Okay. Right. Looking very much like many areas of terraced areas in China, Europe. Okay. Chilean. So these quarries are effectively strip mines. Okay. I don't know if they're just using the name quarry as a coverall, right? Sometimes they're extracting stone, aggregates like we were seeing, sand, gravel are high up on our list of things that we consume, right? And that's by design, guys. Okay. Okay, so we took a look at some of those. Let's take a look at some more quarries here. So focus on these shapes going on here, right? Diamond mine in Russia. Now, the interesting thing about diamonds is they take extreme pressure to create. Does this mean we had an impact of some kind? Or does this, something else I'll point out is through, nuclear or, high energy explosions, you create the pressure. You create a pressure wave. And that could in turn then create some of these denser minerals and metals. Okay. So there's a lot of things going on that help along this kind of creation cycle of mining. This is in Russia. This is a stone mine or stone quarry. Right. And why they stopped mining this is maybe economically it's just not really feasible anymore. But you can see, they're just raping the earth for all of its materials, right? So, and these are some different looking quarries where they're extracting, more loose materials. Okay. Look at that. Incredible. You see a lot of oxidation happening. And that just shows that there are metals and minerals in this. That's what they're extracting. Okay. Sand or what are known as like riverbed quarries, right? Okay. You want to know why some of these rivers and stuff that were on old maps aren't anymore? Boom. There you go, guys. Excuse me. Oxidation again, showing that there's, iron content in here. Okay. Some nice, looks like granite or marble quarry. Beautiful, right? And you always have standing water nearby, kind of keep things rinsed down. So we're going to take a look now at bucket wheel excavators. Absolutely incredible machines. Incredible. Look at the size of this. You can't even see like a person standing over here. Look at that. Unbelievable, right? The size of like, it's like a city on wheels. Look at how small everybody is out there. Look at that. Okay, so this is just, an example. And these are machines we currently have. So you can imagine if there were larger people, this might be some of the stuff that they, left us because we need to be able to mine on a massive scale. Everything else shrunk down to our size just to make it comfortable for us. Look at this, guys. Incredible. And you see some of these shapes being created, right? And we were told that like Wave Mountain is natural. We'll get into some of the ones we're showed are natural here in a bit. But look at this. Look at this, guys. Note the road is up on pillars or is a track. Okay, everything else is operating on tracks on mud. Muck, 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 muck. Size of that. Look at that. Each scoop the size of, your average truck. Maybe two of your average trucks. And, there are people, a lot of people in here operating this machinery, keeping it going. Okay. Think about the engineering that goes into some of this. Look at the shapes, guys. Okay. As you're mining different levels, you're getting different minerals, different compositions. Okay. Incredible machines, right? Incredible machines. Now, we are going to take a look at some artifacts that resemble machines. Look at this fun stuff, guys. Then they're portrayed, of course, as like a creature. Because if you didn't know any better, if you were just, super uneducated, didn't understand what machinery was, just lived out in the forests in some of these reclaimed areas that we were talking about before, right? What would you know? You wouldn't know anything. Like that's why they called these people savages or whatever, right? Because there are populations that are, in these outlying areas that have never seen machinery like this. We've never seen it. So if they were to create artifacts and they know like their dad or their grandparents were taken to these dragons, they were taken to these monsters, and maybe they never came back. Maybe they did come back. Maybe they explained to them how these monsters just ate the earth, right? We have some paintings of like Mayan paintings here. Something I'll point out and we'll get into here in a second is the color scheme of this. Red, white, black, yellow. Very key colors in the process of alchemy. Okay. Right. So if you didn't know any better, you would look at some of these machines and think, wow, those are gods. Look at those gods moving mountains, those gods. Right. Just a thought. All right. Make of it what you will. But then we have sites, created for the worship of these gods. Look at these guys up here with their jackhammers. Okay. Let's look at some natural formations, guys. Well, we're told are natural. And you're going to see the exact same thing. Okay. The exact same shapes. So, at what point do you go, okay, maybe there's something to this, right? But it's hard to look at this stuff with, and this is in Antarctica here. Incredible, right? I don't know why Antarctica is covered with ice and stuff and everything. It's creating pressure necessary to consolidate all of the minerals and wealth in these areas. So there's a good chance that yes, maybe North America was covered in ice and everything. And so you had this process happening over and over again in different areas. And this would explain why there's a polar shift, quote unquote, going on. Okay. Because all of the areas outside of the area that we are currently in, that's illuminated by the sun and so on. That's if you go based on the flat earth kind of thing. All right. Some, don't believe in that. Others, I don't really care what the shape of the earth is. Bottom line is this is happening. Look at this. You're going to tell me this is subduction, induction, duction of types. Okay. Or are we helping to facilitate this process that I pointed out here? The trapping of nanoparticles. Okay. It's a lot. It's a lot to stomach for a lot of people. Okay. But look at this, guys. More natural. Okay. And then once you're done mining it all out, you move to the area next to it and you pump your tailings and overburden over here. Nice oxidized red soil. Ask yourself, how do these little mounds wind up here? I'm telling you, mining explains a lot of this, guys. For a long time, I was looking at the Grand Canyon thinking it was specifically an electrical scar, but, some of it may just be the fractal nature of existence that is creating these Lichtenberg type figures here. But a lot of these shapes, a lot of this stuff, like this is very easily explainable with mining. Is there an energetic process that they also use? Possibly, right? Because the bottom line is we don't know what happened before we got here. We hardly know what has happened since, humanity as we know it. A little book with like something like 88 books or 66 or whatever, whatever the book number is now, but it used to be over 300. So we used to kind of know about a lot of this stuff. So those were some natural formations. Let's look at some more natural formations, right? Okay. Then you move the people over to these reclaimed areas. You see how this is a big cycle now? You see how massive some of the machinery and things used to be? This looks like it was blasted out, drilled down, blasted out. Okay. This is in Appalachia. So you see after a certain period of time, after, enough sediment piles up, you move enough organic material into an area and it grows again. Okay. I know it's a tough pill for a lot of people to swallow. Okay. But this process of organic matter living, dying, and cycling into the ground creates chemicals in the ground that then leach through the rock and create this process, concentrating precious metals. Okay. So hopefully, I've given you enough examples and enough proof to show you more natural formations, right? Okay. 90-degree cuts in rock naturally, right, guys? Come on. Come on, let's be reasonable. right? Have your machine sitting up here or down here, scooping, reaching over, scooping, scoop, 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 all the way around in a semicircle. Move it over here, do it again, move over here, do it again. Or you know, you can choose to believe that millions of years have done this. Now, I'm not saying that there is not an extended period of time that helped to facilitate a lot of what we see. You know, we're used to thinking about time in a very limited manner. We're only here for 80 years. So, okay, more natural formations, right? Panorama of a town in France. Those, look at those guys. What do you think? What do you think? Does it look similar to you? Because guess what? It is spoil tips. All right. And I bet you a lot of these people living here, they have no idea that that's what that is. Okay. This is more overburdened spoil tips. See? Strip mining in Germany. So guess what? The future humanity is going to get to look at this and say, oh, that's natural. They're going to tell them. Sweden, 1970s. Okay. All right. We're kind of getting the point. Popularly known as Kalimanjaro. Interesting stuff, right? So I went from the thread on over to what Wikipedia shows. So if if you're in denial about this stuff, go look at your mainstream sources. They're saying the same thing. Okay. These are all spoil tips. All right. You see where these pictures are pulled from now, right? This is not just somebody making this crap up. Well, maybe it is. Maybe it's everybody making this crap up. But are you gonna buy everything you're sold? Or are you gonna look at the evidence? Sure, it's just a photo. No, I've never been to these places, but come on. How many examples do you need? Goes on and on and on. Now, I don't think we have to worry about the next generation of smaller yet humanity coming in because we're on the cusp of what we call artificial intelligence and robotics and things really looking like it's going to take the place of we as humanity. Does that mean that we as humanity get to move on up and possibly not perform this mining anymore? Possibly, right? So you can see how we're getting to the limit of what we're able to extract from this place. So let me jump back in over here. We looked at artificial spoil tips, some colorful iron copper type spoil dumps. These are artificial. Okay. We'll look at 8 artificial ones here. 1, 2, 3. You see the process happening here. 4, 5, 6. Looking very much like the entire Australian outback from what I've seen in pictures anyway, but looking also a lot like the Southwest United States. See how this is taking place. Now, again, the interesting thing is once you get done, you can go ahead and where'd my reclamation thing go? I lost it. Lost my mining reclamation thing. Anyway, so you see that when they're done there, they quote reclaim the land, and they get or as they're finishing up the mining operation, they'll like put topsoil back down, and then it turns into, like the Midwest. Interesting stuff, guys. Okay, let's look at some natural. Again, I'm going back and forth between these. I think it's important to understand. Let's look at some natural formations. Okay. Um, Also, we have some situations like volcanoes happening. Really makes you wonder about the processes going on when it comes to these volcanoes, because when you're dealing with volatile chemicals, you're dealing with this leaching process, you're dealing with radioactive decay of uranium, creates a lot of heat, right? And thereby it will, hydraulically it kind of moves, and again we go back to this, guys. Trapping nanoparticles. This is what it's all about. Okay. This is why they leave it all laying there. They're like, listen, we extract that's the cheapest for us to do now. The next group goes back and extracts. Meanwhile, these chemical processes happening are creating events like this. Okay. So this is a very alternative outlook on geology. Okay. So it may not be your cup of tea, but keep in mind, we're told that this is all natural, guys. This is not. We're told that this isn't, and we're told that this isn't, right? But when we get over here, oh yeah, that's natural in Argentina, though. That's natural in Argentina. And come on. Uh, does it really look natural? You really think that the earth is shifting sideways and shoving this stuff up like that? Or do you think it's, a little bit more reasonable to think that something is just putting this into piles here? Now you might ask yourself, well, why don't they just keep each individual layer within its own grouping? Because the chemical process has to happen to consolidate the more valuable aspects of this ore. All right. Mount Fuji, massive spoil tip with some decay happening underneath. Now, see, when you get to such a massive size, that creates the pressure that you need to naturally refine and smelt a lot of this material that's down underneath here. This is why you would layer it up in a different manner. Kamchatka. Okay. Nice semicircles here. So I'm just pointing this stuff out as not only me, but others have seen it too. This is Kazakhstan. You see why some of these areas are hardly growing, right? Especially if they've removed all of the water from this area to process all of this stuff. Okay. Now that volcano is creating heavier elements in here or consolidating those elements and excreting the gas, which goes into the atmosphere, which adds to the caustic nature of rain, which flows back through the earth and creates the process once more. So this is all the stuff they don't tell you. And there may be some structures and things underneath a lot of this shit that they just pumped all this crap up on top of. Maybe. We don't know. They won't let us dig in a lot of these places. I don't think you'd want to dig in a lot of these places. Peru. A lot of this is beyond us because of the scale, right? Because of the scale of what's going on here. You know what I mean? Entire area kind of just desolated, decimated. Boop. Little spoil tip in the middle there. Another volcano. And note that, they will tell you that the reason nothing grows on here is because this is pumping stuff out of the top. That's a good part of it. But what is coming out of here is pretty caustic, pretty nasty stuff. um, pretty bare elements, and you need organic matter to create like a topsoil. So once this thing, and think about it, because of the size of this, it's not going to stop ever pumping shit out. So when they say there's a dead volcano, it just means that, you know, whatever was inside that was creating the radioactive decay has either been extracted or has been pushed out naturally. Okay. Incredible stuff, right? Look at this. All right. So these processes are important for the extraction of these materials. You can see Vesuvius has been, quote, dead for a while, right? So once something kind of dies down, or once they're able to, it's neat. There's a nice little road here. I wonder what that's about. So that's just some of the evidence, you know, that we're seeing here. It really, it adds a lot of questions, but it gives us some answers, right? Some answers as to what the heck's going on here. Okay. You might be asking yourself, well, how would they get to these areas? Well, airships, guys. Uranium concentrations, a lot of which are alongside old gold deposits. A lot of these areas, the gold and stuff is mined out. What's left over is uranium. Okay. Grand Canyon, all this gold's mined out, and the spoils, tons of uranium. So some would look at this as a natural process. I'm not so sure, guys. I'm really not so sure. Okay. And then once everything's mined out, guess what? National park, reclaim that land. Okay. So it's incredibly interesting stuff, guys. And, you know, make of it what you will. Everybody's open to their own, you know, interpretation. But I want to just point out briefly, you know, before we wrap up here, a couple of things. Let's look at alchemy itself. Okay. We have the 4 stages of alchemy: the blackening, the whitening, the yellowing, and the reddening. Now, I just want to point out, when you have coal or, you know, oil, it comes out black, right? In the case of coal, you then process it and it becomes petroleum coke or white. Then process that further and you have liquid fuel, which is yellow. You then refine that even further and you have like a higher octane fuel, which is red or purple. Okay, so this is the chemical process, the 4 stages of alchemy. That's in a material aspect. Now, when you look at the spiritual aspect, we have like the Hermetic traditions and things like that. Okay, so let's point out some things in alchemy. In alchemy, calcination was believed to be one of the 12 vital processes required for the transformation of a substance. Alchemists distinguish 2 kinds of calcination: actual and potential. Actual calcination is that brought about by actual fire from wood, coals, or other fuel raised to a certain temperature. Potential calcination is brought about by potential fire, such as corrosive chemicals. For example, gold was calcined in a reverberatory furnace. Okay. See what that is there? With mercury and sal ammoniac. Ammonium chloride. Okay. Silver with common salt and alkali salt, copper and salt and sulfur, iron with salt. So, and mercury with nitric acid. You see all of these components that are used in the extraction of gold, right? And then we turn around and go back and start to extract all this stuff back out again. Okay. And then there's philosophical calcination. Is having to do with living things. Okay. And the powdering of different things. So this philosophical calcination is used a lot in Chinese medicine, or, you know, Eastern medicine. Okay. And we see how they use towers here to create this calcination process. That's interesting in itself, as we see a lot of evidence of tower structures in the old world. So Okay, so that's just one of the processes, one of the 12 processes here. Calcination, solution or dissolution, separation, conjunction, putrefaction, which can also be known as decay. Okay, so we have radioactive putrefaction, right? Congelation, or the gathering up, crystallization. Okay. Sublimation, from solid to gas without passing through liquid. Fermentation. Okay. Metabolic process in organics. Multiplication. Okay. This is an extracting process. Projection, the ultimate goal of Western alchemy. And that's kind of transmutation. Now, if you think that the alchemy going on is not transmuting things into gold, look at what we start out with, guys. Look at what we start out with. Ore, right? And then we wind up with gold. So does that mean, man, I gotta say, does that mean we are the philosopher's stone, each and every one of us, helping to facilitate these processes? It's a possibility. So, I really hope that wasn't too dry for everybody out there, but I think it's very important to look at some of the evidence that we see in this realm, and understand, but not also not be afraid, not be scared by this process that we're being a part of. Okay. We're all at different places in our journey. Some of us aren't quite ready to understand what's going on here. Others of us are, and I hope that this reaches you, you that are here to understand, to grow, and to ultimately perform the alchemy within yourself, to to reach that point of, you call it enlightenment, you can call it oneness, right? Transmutation, right? So there's a lot of that going on in the mining process. And mine is very similar to the word mind. Okay. There's a lot of word magic there at play. We'll get to that another time, but I'm really stoked that you guys were tuning in for this. Hopefully I didn't put you to sleep. There's a lot of information here, and something to look forward to coming up. I'll be getting with Casey of Golden Gate Starfort Command. Shout out to Casey. He's doing some amazing work out there on the West Coast, pointing out different aspects of the Tartarian subject, we'll just call it. I prefer Old World, but he's pointing out a lot of interesting things on his day-to-day endeavors. And so I'll be getting with him. We'll chat a little bit about this mining, and just kind of have a little bit of a conference on it. So I'm looking forward to that, and I'm looking forward to just what comes next, because now that this stuff is put out there, now I can look at understanding the next part of this alchemy that's going on all around us. So once again, thank you everybody for tuning in. I will go ahead and say, please, if you can, rate the podcast, and that'll help maybe get it to more people. Share it around. Hopefully the change in format isn't too detrimental to things, but ultimately I'd rather spend my time presenting the information as I'm finding it, really breaking into these threads and finding out the thoughts behind them and seeing what makes sense, right? So yeah, that's about it. We'll just keep it kind of short and sweet here and wrap it up accordingly. So much love to everybody out there. Have a blessed and fruitful journey, and we will see you next time.